Welcome everyone, Zen Programmer here. Today, we'll dive into feature engineering, a vital process in machine learning and data science. Simply put, it's the art of transforming raw data into features that can help our models make better predictions. This involves tasks like cleaning data, creating new features, and selecting the most important ones. By the end of this presentation, you'll see how effective feature engineering can turn a mediocre model into a powerful one. Please note, I added some Python codes for references. We will not be going deeper into the programming aspect in this presentation. Feature engineering is crucial because better data often beats a better algorithm. It's about understanding the data and creating features that capture meaningful patterns. For example, if we're predicting housing prices, instead of just using the raw square footage, we might also create a new feature like price per square foot. This simple transformation can provide much more insight and help our model understand the data better. The first step in feature engineering is data cleaning. Real-world data is messy. It often contains missing values, duplicates, and incorrect data types. Handling missing data properly is crucial. We can either drop these rows, fill them with statistical values like the mean, or use more advanced methods like KNN imputation, which predicts missing values based on similar data points. This step ensures that our dataset is consistent and reliable for analysis. Next, we need to scale and transform our features. Why? Because features like age, income, or square footage can have vastly different scales. Some models, like KNN or SVM, are sensitive to these differences. Standardization adjusts features so they have a mean of 0 and a standard deviation of 1, while normalization scales features to a 0-1 range. Additionally, we might apply transformations like logarithms to reduce skewness in data, which helps stabilize model predictions. Many datasets include categorical variables like gender or marital status. Since machine learning models only understand numbers, we need to convert these categories into numerical values. One common method is one-hot encoding, where each category gets its own column with binary values, 0 or 1. This method works well for small categories. For larger categories, techniques like target encoding use the relationship between the category and the target variable to encode the data. Feature creation is where we can add a lot of value using our domain knowledge. Let's say we're analyzing sales data. Instead of using just the raw income and debt features, we can create a new feature like income to debt ratio. This provides a better representation of a person's financial health. By combining or transforming existing features, we can often uncover hidden patterns that make our model more predictive. For time series data, like stock prices or weather data, we need to capture trends over time. We can create features like lag features, which use past values, and rolling statistics, which capture averages or variances over a moving window. These features help our model understand the temporal patterns in the data, making it better at forecasting. Multicollinearity occurs when two or more features are highly correlated, meaning they provide redundant information. This can confuse our model and make it unstable. To detect this, we use a metric called variance inflation factor, VIF. If a feature has a high VIF, it might be removed or combined with another feature to reduce redundancy. Outliers are extreme values that don't fit the normal pattern of the data. They can skew our models, especially in regression tasks. Common methods for detecting outliers include the z-score, which measures how far a data point is from the mean, and the IQR method, which looks at the range between the first and third quartiles. Handling outliers properly can lead to more robust models. Not all features contribute equally to a model's performance. Feature selection helps us choose the most relevant features. We can use filter methods like correlation analysis, wrapper methods like recursive feature elimination, RFE, or embedded methods like lasso regression, which automatically remove less important features. This process helps reduce the complexity of the model and can improve accuracy. Manually creating features can be time-consuming, especially with large datasets. Tools like feature tools help automate this process by generating complex features from relational data. It can quickly create hundreds of new features, giving us more options to test and validate. However, it's still important to review these features and ensure they make sense for our specific problem. Once a model is deployed, the data it sees can change over time, leading to feature drift. This means the statistical properties of the features have shifted, which can degrade model performance. To detect drift, we can use tests like the Kolmogorov-Smirnov test, which compares the feature distributions before and after deployment. If drift is detected, we may need to retrain our model. Understanding which features are most important can provide insights into how the model makes predictions. We can use techniques like SHAP values, which explain the impact of each feature on the model's output. This helps us identify key drivers and can also be useful for debugging or refining our model further. Feature engineering is both an art and a science. Here are some best practices. Experiment and iterate. Try different techniques and validate them with your model. Leverage automation. Use tools when possible, but apply domain knowledge for best results. Document everything. Keep track of the transformations applied to ensure the process is reproducible and understandable. In conclusion, feature engineering is a crucial step that goes beyond simply applying a machine learning model. It's about harnessing the full potential of your data, using creativity, domain knowledge, and technical skills to craft features that truly capture the essence of the problem. This process can be transformative, turning raw data into a goldmine of insights that drive powerful, predictive models. Remember, the journey of feature engineering is a cycle of experimentation, learning, and iteration. Don't be afraid to try new techniques, test different features, and embrace challenges. Every dataset is unique, and the process of understanding and shaping it will deepen your expertise and make you a better data scientist. The skills you develop in feature engineering will not only make your models stronger, but will also set you apart in the field of data science. When you create thoughtful features, you're not just making the model's job easier, you're becoming a storyteller, using data to craft a narrative that leads to actionable insights. So, I encourage you to take these techniques and put them into practice. Dive into your projects with curiosity, stay open-minded, and keep refining your approach. Remember, the best results often come from persistent experimentation and a willingness to iterate. With these skills, you have the power to transform raw data into actionable intelligence, driving better decisions and impactful solutions. Keep pushing the boundaries of what's possible with your data, and don't underestimate the value of your unique perspective. Thank you all for your time and attention today. I hope this presentation has given you new ideas and tools for your own projects. I'm excited to see what you create and how you bring your data to life. Now, let's take your models to the next level. This is Zen Programmer. I will see you next time.